the conduct of quantitative research, researchers need to answer the question, how many respondents do we need in our study? Especially if the population is large enough, doing a census will require a longer time and relatively higher cost. Therefore, researchers select a sample from the population. Remember, sample is a subset of the population. Hello everyone, welcome. I am Teacher Sherwin. In this video, we are going to learn how to compute for sample size. In our quantitative study, before we can compute for our sample size, we need to consider a few things about our target population and the sample that we need. We need to determine our population size, margin of error, confidence level, and degree of variability. First, the population size. Researchers need to determine how many people fit in the identified demographic. For example, if you want to know about the willingness of mothers to get vaccinated in a certain locality, it is not practical to conduct a survey of all the mothers in the identified area. Therefore, taking a sample is more appropriate than doing a census. Second, margin of error. In doing a quantitative research, no sample will be entirely perfect. As researchers, we need to decide how much error to allow. By definition, the margin of error determines how much higher or lower than the population mean you are willing to let your sample mean fall. Often this is expressed in terms of percentage. Example plus, minus 5%. For example, a researcher finds that 70% of the students selected the modular learning approach with a margin of error of plus, minus 5%. Then the researcher can conclude that between 65% and 75% of the students in the population have selected modular learning approach. Third is the confidence level or the risk level. This asks a question to the researchers. How confident do you want to be that the actual mean falls within your confidence interval? The most common confidence intervals are 90%, 95%, and 99%. The key idea for confidence level tells the researcher that if the population is repeatedly sampled, the average value of the attribute obtained by those samples is equal to the true population value. Fourth is the degree of variability, or the standard deviation. This asks a question, how much variance do you expect in your response? Since we haven't actually administered a survey yet, the safe decision is to use 0.5. It is often used in determining a more conservative sample size, that is, the sample size may be larger than if the true variability of the population attribute were used. Let us consider this example. For population that is large enough, Cochran 1963 developed this equation to compute for the sample size, where n sub 0 will be the computed sample size. Z is the critical value of the desired confidence level. E is the desired margin of error. P is the estimated proportion of an attribute that is present in the population. And Q will be computed by 1 minus P. To illustrate, suppose we wish to evaluate a statewide agricultural extension program in which farmers were encouraged to adopt a new farming technology. Assume there is a large population, but that we do not know the variability in the proportion that will adopt the new farming technology. Therefore, assume p equal to 0.5, and suppose that we desire a 95% confidence level and minus 5% margin of error. First, we need to get the value of z. Remember that z is the critical value of the desired confidence level. The value of z at 95% confidence is 1.96. Substitute the values in the given equation. At 95% confidence level, 5% margin of error, and an assumed variability of 0.5, the required sample size is 385, or 385 farmers. Let us try this another formula of Yamane 1967, where small letter n will be the computed sample size. The capital letter N is the population size, and E represents the margin of error. This should be remembered clearly, that this equation assumed a confidence level of 95% and a proportion of 0.50. Again, this equation assumed a confidence level of 95% and a proportion of 0.50. Suppose there are 2,000 farmers in certain locality. You want to conduct a survey on their willingness to adopt the new farming technology. The margin of error is 5%. Using the equation, we need to have 333 farmers to be respondents in our study. In this video, we learned how to compute for sample size.